Good morning, everyone. I am here again to discuss another topic of the subject, which is the pharmaceutical organic chemistry in laboratory activity output. By this time, we use again another technique in our laboratory experiment, and this is called steam distillation. So what is the steam distillation means? In order to know the meaning of this steam distillation, we are going to know first our aim. Our aim in this experiment. Aim is what we call the purpose. So, our aim is to obtain pure components from a mixture of unorganic compounds. We are here in the principle of the steam distillation. A steam distillation technique is used for separating substances which are immiscible with water. So, the steam distillation daw na technique ay ginagawang sineseparate nila yung substances which are hindi humahalo, immiscible with water, hindi humahalo sa tubig, volatile in steam, and having high vapor pressure at the boiling temperature of water. Consider two immiscible liquids. In the mixture of one liquid cannot mix the properties of the other. So each liquid behaves as if the other is not present. Therefore, each liquid will show its vapor pressure, but the sum of the vapor pressures will be much higher than the vapor pressures of liquids. Hence, the mixture of two immiscible liquids will boil at a lower temperature than the normal boiling point. So, this method can be used for purifying liquids with very high boiling points. Example is the aniline. Next, if water is used as one of the immiscible liquids, the method is called steam distillation. It is also used for purifying liquids which is decomposed at their normal boiling points. Example, the glycerol. This technique is used for separating organic compounds from plant parts. Example, lemongrass oil or eucalyptus oil, etc. Then the steam distillation process works on the principle that when a mixture of two or more undissolved liquids are heated, while ensuring that the surfaces of both liquids are in contact with the atmosphere, the vapor pressure exerted by the system increases. For example, the boiling point of bromobenzene is 156 degrees Celsius and the boiling point of water is 100 degrees Celsius. But the mixture of the two boils at 95 degrees Celsius. Thus, bromobenzene can be easily distilled at a temperature of 61 degrees Celsius below its normal boiling point. We have here also the basic importance of steam distillation. Number 1 is steam distillation is used to separate heat-sensitive components. Number 2, steam is added to the mixture, causing some of it to vaporize. This vapor is cooled and condensed into two liquid fractions. Sometimes the fractions are collected separately, or they may have different density values, so they separate on their own. Number three, an example is steam distillation of flowers to yield essential oil and a water-based distillate. Number 4, steam distillation is employed in the isolation of essential oils for use in perfumes. Number 5, steam distillation also is an important means of separating fatty acids from mixtures and for treating crude products such as tall oils to extract and separate fatty acids, soaps, and other commercially valuable organic compounds. Steam distillation was invented by the Persian chemist Ibn Sina, known as Avicenna in the West. In the early 11th century, he invented it for the purpose of extracting essential oils which are used in aromatherapy and the drinking and the perfumery industries. Here is the example of the process of steam distillation. Requirements: chemicals. We have the, as per specific requirement, we have the bromine water, no more than 0.2 degree volume per volume. We have also the potassium manganate. We have the cyclohexane, which is highly flammable, then harmful if swallowed. Cyclohexane. Reminder that this is a highly flammable and can cause skin and respiratory irritant. Then, we have distilled water, which is 100 ml. Glass apparatus. We have also the requirements of glass apparatus. Number 1 is for eye protection or the what's called the goggles. Number 2, the grater. The grater that we use in the kitchen, pwede rin yung gamitin. Then Bunsen burner, heat resistant mat, tripod and gauze, oranges, 2 orange, then the thermometer of 1100 degrees Celsius, measuring cylinder which the volume is having the 100 ml of measures, then measuring cylinder which is 550 ml in volume, then the distillation apparatus. The distillation apparatus, which can we see in this, what we seen on this picture. Ito yung distillation apparatus natin. Then the 250 ml round bottom flash, steel head, thermometer pocket, condenser, receiver adapter, test tubes and banks, dropping pipette, anti-bumping granules, and the oil bath. Then we have here in the importance of extracting limonene from oranges by steam distillation. The peel of oranges is boiled in water and the oil produced, which is called limonene, distilled in steam at a temperature just below 100 degrees Celsius. Well, below its normal boiling point. The immiscible oil can then be separated. Direct extraction by heating would result in decomposition, whereas steam distillation does not destroy the chemicals involved. Limonene 1-methyl 4-prop 1 and 2-YL cyclohexane is an unsaturated hydrocarbon class as a terpene. At the room temperature, it is a color least oily liquid with the smell of oranges. Its molecular formula is C10H16 and its boiling point is 176 degrees Celsius. Limonene is a chiral molecule with two optical isomers, or what we call enantiomers. The major biological form, D, which also called limonene, then the R, which is also called enantiomer, is used in food manufacture and medicines. It is also used as a fragrance in cleaning products, a botanical insecticide, and due to its flammability, a potential biofuel. The S, enantiomer, limonene is also used as a fragrance but has a penny turpentine odor. Let's go to the procedure of this experiment. Now, step 1. Step 1, we grate the outer orange colored rind of 2 oranges and add to 100 ml of distilled water in the 250 ml round bottom flask. Add anti-bumping granules to the ground bottom flask. Number 2, set up the distillation apparatus as shown in the apparatus section. Number 3, heat the flask so that distillation proceeds at a steady rate, approximately 1 drop per second of distillate. Note that take care not to let the liquid in the round bottom flask boil too strongly. Number 4, collect approximately 50 centimeter cube of distillate in the measuring cylinder. The oil layer will be on the surface. Number 5, using a dropping pipette, carefully remove the oil layer into a test tube for the next stage. Step 2, odor. Odor cautiously smell the extracted oil by wafting the fumes towards the nose. Do not breathe in directly from the test tube. So the step 3, action of bromine water. Measure out approximately 1 ml of bromine water into each of these 3 test tubes. Number 2, add a few drops of the limonene oil to one test tube, a few drops of cyclohexane to another, and a few drops of cyclohexane to the third. Place in the banks and agitate. If the bromine water is decolorized, the molecule contains double bonds. Then number 3, 0.001 m potassium manganate can be substituted for the bromine water for class use. Then we have the result of this technique or experiment. We achieve the extraction, or what we call steam distillation, the extraction of pure components from a mixture of organic compounds, or the what we call limonene, was performed. So the bromine water is decolorized, hence confirming that the molecule contains double bond or limonene as compared to cyclohexane. So that's all for this topic, and thank you for the listening. Once again, thank you and see you again to another discussion.